Guys, Accelerated Algebra 2, 1.6a. So you just finished the PSAT slides. Today should be Friday, October 9th, which means I'm probably coming back pretty soon. Um, so what you guys are doing today is the part A of the last chapter in Unit 1. So it'll be 1.6a and 1.6b. They really have nothing to do with each other. Oh well. There's your essential question and your objectives for today. So it's basically two mini lessons in one. So just a quick little warm up. Don't do it on the teacher pad, but pause the video, figure out this one, and hopefully we can take off from there. All right, so if we did this one, a lot of people would subtract 18. I'm sure most of you guys subtracted 18. I find it easier just to add x. It really doesn't make a big difference. But if we add 4x, we're going to have 22 plus 4x. And then we can subtract 22 and we'll get negative 4 is greater than 4x divided by 4. And you will get negative 1 is greater than x. I would always get in the habit of rewriting these as x first. So, it's a comma. I'm going to read it as x first, which if I read it as x first, that's x is less than negative 1. Reading it from right to left, x is less than negative 1. That way it's easier to graph it. So that's kind of what I would say my final answer would be. Certainly, if you did not, if you did subtract 18 and then you divide by a negative 4, just remember when you divide or multiply by a negative number, the sign will flip. But very easy to check this answer. Pick a number that's less than 1 and make sure it works. Less than negative 1. So negative 5 million, 18 minus 4 times negative 5 million is going to be 18 minus a really small or really big negative number. So you're going to add, it's clearly going to be bigger than 22. So you got a good answer. Compound inequalities, again, just kind of more of a prerequisite into the lesson that we're going for, but it's an inequality that's either an and or an or inequality. An and inequality, if you do them on a number line, means, you got those two numbers and you're shading in between. An or inequality, however, if you got these two numbers on a number line, right, an or inequality means you're shaving to both sides, right? So that's the difference between an and an or. So solving and inequalities, sometimes this answer is sandwiched between two. So you would write your answer as like an X in the middle. I'll just kind of give you an example in a second. You can solve them separately or you can solve them all at once. I'll do an example where we solve them all at once. I just need to scroll down. So this one, right? This is a typical question with an and inequality. So you can see it's an and inequality. You're going to have basically the X sandwich in between. Pretty sure you've seen these before. You would add 9 to all, yikes, to all three sides. And negative 9 or negative 3 plus 9 is 6, less than or equal to just the 3x now, and less than or equal to 21. And then you would divide both sides, divide everything by 3. 6 divided by 3 is going to give you 2, is less than or equal to x, which is less than or equal to 7. And that's your answer. You always want to write these and inequality answers as basically the x's in between the other two. Again, if you read it x first, it's going to say x is greater than or equal to 2, and x is less than or equal to 7. Right? So you got to check and make sure that makes sense in your head. Okay, it's bigger than 2 and less than 7. Okay, that makes sense. It's not like I said less than 2 and bigger than 7, which wouldn't make sense, right? It's bigger than 2, less than 7. Okay, there's some numbers in there. If you wanted to do it on a number line, right? All I need on a number line is just include those numbers, 2 and 7. You don't need to give me, 0 through 10 here and make this pretty number line. Just make it enough so that I know you understand exactly what the answer is, right? So you'd fill them in with circles because they could include it, Open circles means it does not include it, so we want to fill these ones in, and that is all you would do. All right, an OR inequality. So this is going to be the ones where you kind of going all the way left and all the way right. Solve and graph this one. So it even says the word OR right there for you. Kind of tells you what it is. So these ones you can't do in one step. You're going to solve them separately. So you would subtract 3 here. You're going to get 2x is less than 4. Divide by 2. You get x is less than 2. And then we have an OR. So we're going to add, or we're going to subtract 5. And we're going to get 20. And then we're going to divide by 5. We're going to get x is greater than 4. Now, even if it didn't give you the word OR, you could still figure it out, right? It's a number that's less than 2, but greater than 4. Well, there is no number that's less than 2 and greater than 4, right? So that tells you that it's an OR inequality. It needs to be one or the other. It can't be both. That's why it's not an and, right? There's nothing that fulfills both parts. So we would have open circles on both of these because they're not including those numbers. And we're going to shade all the way until negative infinity. And we're going to shade all the way into positive infinity. And that would be your answer. Okay, so now the mini lesson with the absolute value inequalities, which I think is actually, that is your only lesson. It's not really split into two. We got a couple word problems. That's okay. All right, so absolute values. This is kind of showing you there's two answers here, right? And if you think why, well, because, if you get a negative inside the bars, then when you take it outside the bars, it becomes positive, right? When you do the absolute value, it becomes positive. And if it was already positive, then it becomes positive as well. So there's two conditions that will work for the numbers inside the bars, right? So anytime you're going to do these, your first step is to get whatever the bars are, whatever's inside the bars and the bars by themselves. So you can see they're going to add 4 to both sides, so they get the absolute value of 3x, absolute value of 3 plus x is less than 4. Same on both sides, right? So the first one, the first case is you simply just ignore the bars and you solve it, right? So 3 plus x is less than 4, subtract 3, get x is less than 1. Easy case. However, you got to think if 3 plus x came out to be negative 4, that still works, right? Because if you had negative 4 and then you took the absolute value of it, you would have 4 minus 4, which is, equal to 0. So in this case, it's the same thing. You're going to do a 3 plus x, but you're going to go greater than negative 4 because for the same exact reason. If you get really negative number in here, that's okay because it'll be really positive when you take the absolute value of it. Or actually probably the other way around since you're greater than negative 4, but it's really the same principle, right? So your two cases, you drop the bars and you solve it exactly the way it's written, less than, drop the bars, right? Still less than. The other one is you drop the bars, you don't change anything on the inside, still plus, still plus. However, you flip the inequality and you make it negative. So it's kind of like you got to do 2 steps with the case 2, right? And then you get x is greater than negative 7. So you got x is less than 1 and x is greater than negative 7. So you got to think, is that an or an and inequality, right? Well, if it's less than 1, it can still be greater than negative 7. So that's an and inequality, right? There's numbers that fit for both, like 0. 0 is less than 1, 0 is greater than negative 7, so there's numbers that work for both. So that's why we say it's an and inequality, and you want to write your and inequalities like this, sandwiched in between. There's a second example right here, right? You got absolute value of x plus 2. So first case, ignore the bars and solve it. The second case, ignore the bars, but then flip the inequality and make it negative 2, right? And then you get negative 4. Again, you should be checking these answers. It's pretty easy. Plug in a number that's bigger than 0, like 5. 5 plus 2 is 7, the absolute value of 7. Yep, that works. Right? Now it says x is less than negative 4, so if we did like negative 10 plus 2 is negative 8, but when you take the absolute value of it, it's positive 8. And that's why you flip the sign, and that's why you make it negative, right? Otherwise, it wouldn't work. So if you look at these answers, you're saying greater than 0 and less than -4. Well, there is no number that's bigger than 0, but somehow less than -4. So what does that tell you? It tells you that it's an OR inequality. It can't fit both, right? So that's an OR inequality. All right. So, when you do absolute values, if it's a less than sign, it's always going to be an and inequality. But, I have found that kids struggle to remember which one's which. So you don't need to know that. It's kind of like you just look at your answers and figure out if it's an and or an or, right? Like I said in the last one, if it's less than, -4 but bigger than 0, that has to be an or inequality because there are no numbers that fit both. But if it was, less than 5 and greater than 1, that's something that fits both conditions. That's an and inequality. So you can kind of look at the answers and decide that after. So if I gave you this one, first case you would do is do x minus 3 is less than or equal to 4. Ignore the bars, right? Add 3, you're going to have less than or equal to 7. But the other case you're also going to have to do is greater than or equal to -4. Again, for the same reason, once you take the absolute value of it, it's going to be back to positive. So even though it's going to be more negative this way, it's okay. So here we're going to add 3 just like we added 3 in the first step. Again, it's still minus. A lot of kids want to change it to a plus or change inside. Don't. So you're going to get x is greater than or equal to -1. And then ask yourself, okay, it's less than or equal to 7. You can do a number line if you want to. And it's greater than or equal to -1. Well, okay, there are plenty of numbers out there that are bigger than 1 and less than 7, so that tells you that it's an and inequality. Right? If you wanted to graph it, I think some of the work you'll have to do tonight and later in the class you'll have to graph, right? 1 to -1 to 7, and again it's in between, right? Less than and then greater than, so it's definitely in between. So that's an and inequality. Now, if it's greater than to start with, it's an or inequality, but again, you don't need to memorize that. Just look at your answers and you can figure it out. So this one, I have, again, same things. You're going to just drop the bars. X minus 20 is greater than 5. Add 20, you're going to hit x is greater than 25. And then the second case would be you're going to go x minus 20, and you're going to flip the sign, and then make it -5. So you're going to still add 20, that step's the same, and you're going to get 15. So you got to think, okay, it's bigger than 25 and then less than 15, right? There's no numbers that satisfy both. It can't be bigger than 25 and somehow less than 15. So that tells you that's an or inequality, so you would want to write the word or right in there, right? Just like in this one, we'd want to include the word and. I actually forgot to do it this way. This one should have been -1 is less than or equal to x. Whoa. I really have no idea what the heck just happened. Is less than or equal to x, which is less than or equal to 7. Right, so that would be your final answer. Sorry, I forgot to do that. Okay. And then this one, you couldn't sandwich it. This would literally be your final answer with the word or right in there. You don't write and, but you do write the word or. Again, on a number line, if you wanted to, or if you were asked to, you got 25, you got 15. Those are the only numbers you need to include in your number line. I don't even need 0. So you're greater than 25, open circle, and be over here, and you're less than 15, open circle, and you're over here. Again, you can easily check it. Plug in a number that's less than 15, like 10, and make sure it works. Yeah, 10 minus 20 is -10. The absolute value of that is 10. 10 is greater than 5. Pick a number bigger than 25. Let's try 1,000. 1,000 minus 20 is 980. 980 is definitely bigger than 5, right? Sometimes I pick really big numbers just to make sure it's obvious. All right, so on your own, this is the last slide before you guys have some practice. So on your own, I want you to just try this one. So I'll scroll down so you can read the whole question, and that's everything. So you can pause the video, read the question, answer all the parts, and then resume the video when you're done. All right, so we got 2 cans of barbecue sauce. So the small one, they want to get 18 ounces of sauce. That's what they want to give you, right? So obviously they have a little bit of leeway. It's not like every bottle of sauce is exactly the same, but they're all within 0.25 ounces of the original 18 ounces. So that 0.25 ounces is what we call a tolerance, right? And so next time when you go to the store and you buy uh, some Gatorade or whatever, right? You might get an extra sip if you buy the right one. It might have a little bit more than some of the other ones, and that happens. But there's a tolerance level that they're willing to tolerate. Maybe they weigh it to kind of figure out if something's over. I don't know. So part A, what is the maximum amount of sauce in ounces for each small? Well, if there's a 0.25 ounces of tolerance, and that's 0.25 is within 18, right? If you just have 18 plus 0.25, the most sauce you're ever going to get is 18.25 ounces, right? Uh, Ounces, O-Z, okay? So 18.25 ounces, show or explain how you got the work. You can literally, if this was MCAS, you could just go 18 plus 0.25 equals 18.25 ounces. All right, so then they give us an absolute value inequality, right? Solve it. So do exactly what you were doing before. You're going to have x minus 18, getting frustrating, is less than, that's 18, there we go, or equal to 0.25. So you're going to add 18. You're going to say, okay, x is less than or equal to 18.25. Now, that's what a lot of kids are going to do, and they're going to say, on the MCAS, they're going to forget to do case 2, and they're just going to say x is less than or equal to 18.25, which is great if you're the company. That means you can sell the bottle even if it's, 0.1 ounces and still somehow make a profit, right? Probably a bad thing for the company because nobody will buy that one, right? So you got to refine your answer, right? As soon as you see this, a red light has to go off and say, okay, that can't be the only answer because it's not like they're going to fill a jar or a bottle of 5 ounces when another one next to it's 18.25 ounces. So you got to do the other side of it. So it's x minus 18, drop the bars, flip the inequality, and say, okay, well, greater than or equal to negative 0.25, sorry. And now when you add 18, you're going to get x is greater than or equal to 17.75. And that now makes sense, right? So are there numbers that are bigger than or equal to 17.75 but less than or equal to 18.25? Yes, everything that's in between those. So your answer would be 17.75 is less than, is less than or equal to x, which is less than or equal to 18.25, right? And that's basically exactly what this whole thing was talking about. So when it says show or explain how you got your answer, if it is an MCAS, something like that, your work is justification enough. If you wanted to give a sentence answer or something like that, you could, but most of the time the work is sufficient. So then when you did this C and D, so we have a larger bottle now, but the same premises, right? They're allowed to have 23.55 or 24.45 or anything in between there. So the tolerance, if you got 24, and that's kind of the standard, and they're allowed up to 24.45 or down to 23.55, the tolerance you can pretty easily tell is just going to be 0.45. So part C, 0.45. If it asks you to show how you got the answer, right, you would just say 24.45 minus 24 is 0.45, and then do 24 minus 23.55 is that same 0.45. So now you're going to write the absolute value inequality, which is kind of like working backwards what they had from here, which represents y, the amount of sauce in ounces that the company allows. right? So you're going to say, instead of x, you're just going to use y. So it's going to be y minus, here you had 18, so here we're going to have 24. And then less than or equal to the tolerance. You don't want to be bigger than the tolerance. You want to be less than or equal to the tolerance. And the tolerance was 0.45, right? And now if you weren't sure if you did it right, you could certainly go ahead and solve it and make sure that you get something that looks like this one up here that I did, but less than or equal to 24.45 and greater than or equal to 23.55. But that should have been your answer. Again, the MCAS kind of gives you a hint at what the answer should look like in the above section. So what you're doing for the rest of this class is going to be these 10 problems. So if you want to just kind of pause this screen, because you got 3 here and you're going to get 7 in the next screen. So if you wanted to pause this screen, I'm not sure if they're on your classwork or not. Actually, you don't have classwork. These are just kind of your own notes. You can pause this screen, write these ones down, and then now go ahead and pause this screen and write those 9 down, and then get that 10th one in there somewhere. So you can do it in pairs. I don't really care who you work with. It's Friday, so pick who you want to work with, but make sure you get these done, and then I'll give you just the answers for them in a second. But pause the video, work with somebody, and do them, and then resume the video when you're done and check the answers. First one, we should get an answer of 13/12 is less than x, which is less than or equal to 25/6, I believe. So it would be an and inequality. The second one tells us that it's or, which is nice. We should get an answer of a is less than or equal to -6, or a is greater than or equal to -13/77. Next one is an and inequality. We should get -15/2, which is less than or equal to d, which is less than or equal to or actually just +3 from that first one. All right, so moving on to the next slide. These are good ones, these first couple, right? If I did the absolute value of p, right, that less than means it should be an inequality. But when you think about this, and you want to take a step back with some of these ones, right? When you subtract 7, you're going to get -4. Well, let's just think about this equation right now. So I have the absolute value of p, which is less than -4. The absolute value, the numbers have to be 0 or positive. That's the only possibility for an absolute value. So if you have an absolute value and it's trying to tell you that it's going to be less than -4, meaning a negative number that's even smaller than -4, that's not possible. So you're going to get an answer of never, right? So as we said before, if it's a less than, it should be an and inequality. And if you actually went ahead and solved it, you would get p is less than -4, and you would get p is greater than +4. Well, that's an or inequality, but it should be an and inequality, so it actually does not make sense when you think about it that way. So the answer is actually never. That will never be the case. Doesn't matter what you plug in for p, it won't work. Right? Really negative number, really positive number are just going to add to the value of p, and then you're going to add 7 to it. It's never going to be less than 3. Number 5, we should get, that's an or inequality, we should get something like j is greater than or equal to 6, or j is less than or equal to -2. Number 6, we will have, I think, greater than uh, -13 and less than -3. So that would be, yeah, it's an and inequality. So we got -13 is less than x, which is less than -3. All right, this next one, we should get less than 9 and greater than -9. So that would also be an and inequality. Again, it's less than. So we got -9, less than n, less than +9. So anything in between there should work. Next one is going to be another kind of weird one here. You're going to subtract 3, you're going to divide by 4, so you're going to have an incredibly negative number. You should end up with something like, the absolute value of 3x plus 7 is going to be greater than or equal to negative, I think it's going to be 23 when you do it. -23. So again, take that step back and say, okay, it's an absolute value, right? So it has to be 0 or a positive number as a result. Doesn't matter what you plug in for x, it's going to be 0 and positive. So it's trying to say a 0 or positive number is going to be greater than or equal to a -23. Well, that's always going to be the case because any positive number or even 0 is greater than or equal to -23. So that's an always, right? So the fact that it started with a greater than or equal to sign, and then when you did it, you would get that's an and inequality, which is usually a less than sign, is kind of a red flag. So this answer is always. But again, kind of take that step back when you get to that absolute value by itself and just evaluate it really quickly. Number 9, we would have another one where it would be like an always again. You should get something like, when you simplify it before you break it up, you would get your 2/3 x minus 5 inside. And then on the outside, I think you would subtract 11/4, so you get 21/4, -21/4. And you would have to divide by the -1, so the sign would flip, and you would get -21/4, I believe. Certainly could have messed up somewhere along there. And again, take a step back, right? Absolute values got to be positive or 0. And a 0 number is greater than a negative number, or 0 is greater than a negative number always. So that's another one where the case is always. And the last one, right, is to give you this really nasty problem on purpose because it's actually very easy. If you got a positive number or a 0 that results from an absolute value, which they all have to, that will never be less than -1. Positive numbers are never less than -1, so that one is a never. And those are your 10 problems, right? So all you can do now, if you finish the slides and you still have some time left, this is your homework. It's on Schoology, and go ahead and do those.